Hello. Welcome to our talk on, or we can pass it back and forth too, but yeah, that's probably better. We're going to talk to you guys about onboarding mainstream users into Web3 with Discord and Lit. This talk is about how you can use Lit with Discord to super easily onboard your users with wallets. So.
Hello, welcome. My name is Raymond, and I work for Abridged. So I'm so glad to be here on the stage with Chris. We have been working so hard together for months because we are doing very interesting joint research project to figure out what's next for onboarding massive users into Web3.
Yeah, so Raymond, do you want to take us away and explain your dream wallet?
So I have been working on crypto for 2 years, and I come to crypto from a traditional Web2 background, right? So even though I claim myself as a technical person, but I still struggle quite a bit to onboard myself into Web3. And the first thing we are thinking about is a wallet, right? So the wallet is your ticket to Web3. But at this moment, the wallet has a lot of issues. And the most critical one is I have to take the full responsibility to take care of the seed phrase or private key. I don't know how you guys store your private key. I wish I could just dig a hole, dip it in the ground, and bury that, right? So I don't want to take that responsibility anymore. And secondly, I want to have more flexibility so I can progressively take over the responsibility. So I don't have my wallet to be owned by Coinbase, but on the other side, I know a lot of users want to start from there, right? So we want to provide paths to get into the process. So of course, as a wallet, I want to have multi-factor authentication and provide that, guidance, social recovery, all this good stuff. Then incrementally, as we're getting deeper into the Web3 space, then you use a wallet for different purposes. You could use your wallet as a decentralized ID and a signed message to prove you did that thing or get a credential out of it, or you can do meaningful transactions. Depending on the nature of the wallet, I need to have a way to incrementally upgrade my security, enforce the different authentications, and provide a meaningful authorization, right? And the people also really scared about signing anything today, right? How do we make that signing process a joy instead of a scare, right? Have meaningful message, even have a preview of your transaction, and even allow yourself to decide what's the criteria to sign that transaction. So all these steps will help us to have a much safer place to be. And of course, account abstraction is cool, and it just arrived. I'm excited about it. But still, there's some nuances. For example, I have to deploy the smart contract into the blockchain I'm interacting with. I don't have a universal account abstraction for myself. I may make mistakes, say, hey, I have this account abstraction on mainnet. Then when I work with Polygon, maybe that's not my wallet anymore, right? So those are the things that, of course, as a technical guy, I really want to have that flexibility. I want to make a off-chain smart contract to manage my wallet. Not everything in chain, but it's a collaboration between on-chain and off-chain. So those are my wish list. I bet each of you have probably more on board.
Thanks, Raymond. So I'm going to talk about how, what is Lit Protocol and how it can enable the Dream Wallet. So Lit Protocol is a threshold cryptography protocol. We're trying to decentralize public key cryptography itself. And the way that threshold cryptography works is you do a process called the distributed key generation. This generates a public and private key pair, but nobody knows the private key. Instead, each node only has a share of the private key. And the nodes can both sign and decrypt with those shares. The user has to collect signature shares or decryption shares above the threshold in order to get back the signature or decrypt something. And so we have a network that's live right now, but we're running all the nodes. We're working on decentralizing it. It should be decentralized soon. And this is kind of what it looks like to use Lit to sign a transaction. So on the far left, you have IPFS. Lit has a system called Lit Actions that I'll get into in a minute that basically lets you run JavaScript programs across the lit nodes in the middle. And so you could have a program that like does authorization, anything you need. And if the program completes, then the nodes will sign at the end, and with their private key shares, and then the user collects signature shares from a threshold of nodes and can create a signature. And you can also, and so this is like kind of the right use case for signing. You can also do something similar for access control, where you can encrypt content and you can say something like, you can only decrypt this content if you meet a certain condition, like the user holds an NFT or the user is a member of a DAO. And so that's like what this flow looks like, where the nodes would actually check the blockchain, and then if the user meets the conditions, they'll create decryption shares. The user can combine them to get back the decrypted data. So how does Lit Protocol enable the Dream Wallet? We have a thing called programmable key pairs that we call PKPs. Programmable key pair is basically a threshold key that anybody can own by simply minting an NFT. You can also transfer the key by trading the NFT, which allows you to actually trustlessly trade or sell private keys themselves. That breaks soulbound tokens, amongst other things. But that enables a cloud wallet where the nodes are the ones that actually custody the key for you. That we have a system called Lit Actions, which is a fully programmable JavaScript runtime that gives you access to the underlying cryptographic primitives that the nodes are able to use for threshold signing and decryption. And so that gives you the flexibility to kind of like do whatever you want with threshold cryptography. You don't have to like set up your own network of nodes, threshold nodes, to do things. Instead, you can use our network and just write some really easy JavaScript. And we worked really hard to make it so that you can do things like import regular node modules, and you don't have to like use assembly script or anything. It's like actually pure JavaScript. And we also enabled you to talk to the rest of the internet via HTTP calls. You can use fetch, and so you can pull outside data in. You could use a lit action like in Oracle. The possibilities are really endless. I mean, you could say like the user is only able to sign like on Tuesdays, and pull down like what the date. And the other thing that we have is auth helpers, and auth helpers enable OAuth and WebAuthn. And what that means is that the user doesn't have to have a seed phrase. Instead, the user can log in with like Google or WebAuthn and send their access token up to the nodes, and the nodes can actually check their identity and prove it, and then can tell if they're actually allowed to sign or not. So this is an example lit action, and you can see up at the top here we define a function that will be run, and we define the string hello world for testing as an array, but it can be any data that you could sign, right? You can sign an Ethereum transaction. You could even sign a Bitcoin transaction if you wanted to, I guess. And then we have a function right here, litactions.signECDSA, that actually goes out of the JavaScript context into the Rust context, because our nodes are running Rust, and tells the nodes to use their key share to sign. And there's an authorization that happens in the background here to make sure that the user is actually allowed to sign. This is like a kind of a little complicated diagram of how it works, but you start at the top right up here, and the user has to auth with lit somehow. In the case of the project that we're working on, the user auths with Discord, but it could be an ETH wallet, Apple Passkey, WebAuthn, any public key cryptography scheme, and the lit nodes like take that signature or that authorization proof and pull down the lit action code, which is like the JavaScript code that's stored on IPFS immutably, and they execute that in the JavaScript runtime over here, and they're able to use the cryptographic primitives like the threshold private key share from the nodes, and the JavaScript runtime is also able to access the whole rest of the internet by using HTTP requests. You can pull data down from blockchains. There's like a lot of things you could build with this. And if everything checks out and the JavaScript creates the share, then the signature shares get returned to the user. They could be in a browser. They could be a Discord user. They combine those signature shares, and then you can broadcast that signed transaction. So what other use cases does Lit enable? Lit enables signing automation. So you can, because the nodes are custodying your private key, You can set up things like limit orders, dollar cost averaging. You can have it sign in your sleep. And you don't need to, like the way to do that right now, right, is like a trading bot. You have to have a hot wallet. It's pretty scary. It's a big target to be hacked. You can do a PKP vault because you can trade one of these PKPs as an NFT. You could fill it up with all kinds of assets. You could put Bitcoin ordinals in it. You could, put 1,000 NFTs and sell the underlying private key and trade 1,000 NFTs at once. You could do it cross-chain messaging because you're able to read and write from blockchains. And you can sign everything. Since the lit nodes are able to pull down data from the internet and sign things, you could use it as an oracle to create signatures of any data that lives in the outside world. You can do things like locked NFTs, where only the owner of an NFT is allowed to decrypt it. You can do certification and proofs, which is kind of related to sign everything, but it's kind of conditional signing, I will only sign this if these conditions are met. And because it happens across all the nodes, and we have a 2/3 threshold, 2/3 of the nodes have to agree. And so that you had a sort of consensus on what that thing that you're trying to prove is. And you really can build anything you want with decentralized signing or decryption. And if there's something you can't build, come talk to me and we'll figure out how to change the system so you can build it. We have the docs at getlit.dev, so definitely check those out. Raymond, do you want to talk about some of the challenges of building the Dream Wallet with Lit?
Yeah, sure. We have been really excited about this new paradigm because to me, the only responsibility to have a wallet is to sign and to sign safely, right? Because otherwise nothing could happen. And to me, as long as we figure out a way for the wallet to sign meaningfully for you, that's the end of the onboarding journey. And when I work with Chris and his team, we really try to drive the developer experience from the real world use cases. We design some scenarios and try to enable these scenarios with the infrastructure from Lit protocol. Utilize the Lit actions as a specialized off-chain smart contract. And we build a middleware tier on top of the blind signing because the demo, the code that Chris had early on, it's either just sign a fixed message or just sign everything, right? But that's not good enough for a typical use case. So that's why we kind of going deeper into that user expectation from the developer's point of view. And we ran into a few nuances, but we were able to work together and put on a good fix behind that. So the first one is, for the Lit action as a JavaScript function, you need to have a social truth. And Lit use IPFS as an immutable storage so that when you deploy that code, just like a smart contract, you cannot touch it anymore, right? That's the social truth, which is the IPFS hash ID that you as a user will authorize your PKP to run that code on behalf of you. But one nuance is we run into is, IPFS infrastructure is not so reliable. And sometimes it just fail to load that in time. So one idea we come up is, what if we also allow the source code to be passed to the network directly, then we calculate the IPFS hash ID on the fly, and if that IPFS ID matches your authorization, we can still accept it. So this is a easy, in place source code, but we still guarantee the integrity of your authorization. So that's number one. Number two is talking about our potential use case and the scale to support millions of users from Discord, from any app Web2 platform, which the tokenized communities are collaborating together, right? So we need to have high throughput. We need to deal with the concurrency executions. For example, a lot of backend has rate limiting, right? So imagine you want to authenticate with Discord, right? So you need to get the access token, and inside the Lit action, which is a JavaScript function, we need to make HTTP calls to Discord to say, hey, this credential really represents a user that has been authorized as part of the access control. Right? So that gives us some interesting challenge because this is a threshold-based, consensus-based decision-making process. Multiple actions will be triggered, by one single client to run the things in parallel and then make that 2 out of 3 decisions. So that creates some traffic to the backend we depend on. So we need to figure out how to deal with that. So that's the second one. And third one is as part of the smart contract, you want to have some helper. You want to have some utility to do all these common things, right? For example, you want to verify the signature. You want to have a way to talk to the smart contract that sits behind the blockchain that provides the access control. You need to figure out the different authorizations being given for that PKP. So those are the utilities we would expect do not repeat yourself and have the runtime to inject these utilities to the JavaScript function based upon your requirement. So this gives us a very meaningful dependency injection so we can do these things in a reliable and do not repeat it yourself way. So that's number 3. Number 4 is now if you have a PKP, right? That's your public-facing identity. And to enforce the access control, you need to attach some other identities with that PKP. Say if you want to authorize your Discord ID to that PKP, you want to authorize your email with that, then there's a privacy concern, right? You don't want to disclose your Discord ID, Google ID, your email in the public blockchain, right? So that's another interesting concern. Like on one hand, you want to make sure the ACL on-chain has all the knowledge, but on the other hand, you don't want to disclose all the details, right? So we did a little bit of research into that. So the first approach is we kind of hash this value onto the blockchain, and only the action itself can understand that mapping. Another way is we kind of break the data into off-chain state and on-chain state. So for example, we can build all this knowledge into a Merkle tree. Then we store the root hash of the Merkle tree on-chain. So anytime you present a proof to the action to check the integrity of that access control, then you just have to check if the proof is part of the root hash on-chain. So this way we can have a good, best of breeds approach to minimize the on-chain data, but we still keep that, data integrity in place. So I kind of hint that number 5 thing, which sort of becomes a potential solution for the privacy concerns. Yeah, so I can continue a little bit. So of course, like we build something for a purpose, right? And we fully drive the design and the research from the real world use cases. So we do have a couple of things in our mind how we can unlock the value of the PKP so we can help our users. So first one is we want to emphasize this wallet as an onboarding experience and don't emphasize too much on the financial side of the thing. So just imagine this is your first decentralized identity. You come on board with Web3. And of course, as a blockchain user, which is kind of the first-class citizen for Web3, you need to have the ability to receive some crypto assets as a starting point from some sponsorship, right? So it's very much, you go to a party, you get a goodie bag. And in that goodie bag, you have a bunch of things. Then with that goodie bag, there's a ticket. Then you could go to the next party, right? So that's sort of our idea, like how we can potentially use PKP as a meaningful way to onboard like crypto curious users into the full journey, step by step. Second one, I want to really emphasize, we are kind of blending the barrier or the boundary between on-chain ownership and off-chain ownership, because of course, like fungible tokens, non-fungible tokens are well known to crypto-savvy users as a source of digital ownership, right? But really, it's happening in the real world. You are getting a lot of digital assets by yourself. Imagine we are talking here, then you are, have your attendance in this conference, right? Or like you get a certificate from your college, or even like between the different parties, I can issue so-called verifiable credentials. Basically, it's just a signed message which has the stamp from the issuer and also have the recipient as another wallet or another decentralized ID. Then we have a claim. So everything is digitally signed to protect the integrity of that claim. And that could be independently verified. So these verifiable credentials are becoming even more important for us human beings in this society. Not just say you can use money to buy a lot of digital assets, which are fungible tokens and non-fungible tokens. So those are the interesting use cases. We really try to connect the dots here and allow PKP the real key to unleash the value for Web3. And of course, we hear a lot of announcement, a lot of excitement, like say, hey, account abstraction has arrived, right? And we're kind of really like that movement. And we see the MPC wallet and some other way to do the key management and onboard users together with account abstraction will really becomes a real marriage made in the heaven. So we try to create this best of breeds, best practice, and enable users to have their own choices and provide this incremental upgrade.
Yeah, that's absolutely right. Because with account abstraction, you still need something to sign. You still need a signer. And so combining lit with account abstraction, like just the possibilities explode in what you can build.
All right.
Yeah. Yeah, so yeah, the future is bright. I mean, we're really excited to see like what becomes of our little research experiment, and really excited to see what you guys can build that is like similar or interesting to really help bring more users into Web3 and not have to worry about seed phrases and things like that that are just like such a drag for the average user who's like, it's like write down 24 words and you're like, I'm on a bus. Like, there's people behind me, like I can't, no other product has that amount of friction. And so if we want Web3 to win, we have to really reduce the friction, I think, to the Web2 UX parity. And then I think we have a few minutes left. So if anybody has any questions, we'd be happy to answer those.
Thank you. Testing. So in the event, you have this nice frictionless kind of onboarding experience and somebody's using like a phone number or an email to access this wallet. What are your thoughts right now on, let's say, that advanced user who says, well, actually, I don't like that this is accessible through my email and I want to, you want to do that progressive decentralization and they want to revoke that access and maybe just go with the seed phrase, right?
Yeah, that's very possible. I mean, we've designed this so that you can do what many people call eject from the ecosystem. So yeah, so if you want to use any like auth method that you want that isn't supported by default, you can do that. We have like a series of smart contracts that you can use to create permissions, and so it's basically like as easy as, if you have a Discord wallet and you're like, oh, actually, like I got a ledger and I don't want Discord to be authorized anymore, you would use your Discord wallet to authorize the ledger, and then you could use the ledger to revoke the ability for the Discord wallet to sign anymore. Yeah.
Yeah, just to add a little bit color to that, really the key here is to decouple the key management from the interaction and controlling of the signing process. And when it comes to the controlling of the signing process, it's really this fine-grained incremental authorization we can do and enable user to pick up the right path. And even learn from the community, we could have well-defined templates for them to define different kind of rules. Then from the credential perspective, imagine you are part of a Discord community and you get your first PKP wallet. So of course, at that point, your Discord ID probably is the single controller of your wallet. That's fine because at that point, there's no meaningful assets in that wallet. You're just doing some experiment with the Web3 journey, right? Then over time, say, hey, I really like this wallet experience, and I want to use that for small transactions. Like, say, I want to send a tip inside Discord. Say, hey, I want to give some tokens to Chris. So that involves the next step of the journey, which is on-chain transaction. So maybe this is a good trigger. We tell the user, hey, now you try to do an on-chain transaction, you'd better upgrade your security, right? And that upgrade could be a traditional 2FA. Say you need to register secret, and you kind of do that from Google Authenticate to get this 6-digit code and use that in addition to the Discord ID. Then from the Discord ID perspective, because that's tied to a Discord user, it's not tied to application ID, right? So maybe you want to protect the user, you don't want to allow some third-party app to trick the user to get the access token for the Discord ID, then use that access token to unlock the PKP. So the user can decide, I trust this bot application from XYZ, but I don't trust this bot application from ABC. So that means he can add one additional factor to the system that only the access token coming from XYZ can sign the transaction, right? Then even more like say, hey, not only I'm sending 5 tokens to Chris, I'm sending like 1,000 tokens, right? So that moves the next level. So I would say, oh, maybe you need to enable the passkey, right? Because to me, passkey is the other side of the world. Like you have everything local on your device and provide this key management and have a meaningful signature exchange between your device and some service out there. So this PKP really, it's kind of the buddy, in the cloud, then you kind of have a remote control to control what you do. So for that to happen, say you want to enable your passkey so that you have to sign with your passkey in addition to Discord, or you say I need to have a MetaMask wallet, and I use that MetaMask wallet to sign a message in addition to the Discord credential, in addition to the passkey, right? So this is really the idea, like we have this incremental path, depending on the nature of the usage of the PKP, you will be, put into a guardrail, getting there step by step. As you are learning the responsibilities, you are taking more responsibilities.
Yeah, that's right. And if you guys aren't familiar with passkey, just to make sure that that's totally clear, that's the Apple implementation of WebAuthn, which is, it's like basically you scan your face and create an account, and it's like a single button to do this within your phone. And it generates a private key for you to use for authorization, signing into things, and syncs it across all of your iCloud. So if you lose your phone, you can still get back in. And I think that's probably one of the easiest, most secure onboarding flows for new users. So we're really excited to see what people build with this. And yeah, check it out, getlit.dev.
Thank you.